Let me think about this. Is that okay?
Yeah.
Okay. Maybe I'll put it on this.
Oh, sweet. Hi, my name is Arian Jadbabaie. I'm a senior studying physics with a minor in math. I was originally doing physics and philosophy, but didn't really like some of the philosophy stuff to watch here, but no worries. And so before, so as you can see, the title of my talk is Why Be Cosmos. I figured if I'm giving you guys a look into my headspace, I should give you a look into my poor sense of humor. And first, when I say physics and philosophy, how many of you guys think, like, how are those two related? Like, are these, maybe you don't. Talking about certain aspects of them that, in my opinion, have a lot of parallels with physics. So let's get started. Word. Okay. So where are we gonna go? This is an Einstein quote, but you can't really read it. But the point is, Albert Einstein has a quote where he says, "Look, a human being is part of the universe, and we're part of this. We're this very tiny part of this very big thing called the universe. We do experience ourselves, our thoughts and our feelings, and that's considered separate from the rest of the world around us. He calls this a sort of optical delusion of consciousness, where we see the world just from our perspective. And even though we know other people exist, we don't really think that the world exists on this multifaceted way. We really just look at it from our perspective, and when we try to understand it, we try to understand it from our perspective. And my goal in this talk is to talk about getting out of that optical delusion. And I feel like we can get out of that when we look at the world on different scales. When we look at the world just from our perspective, we see things just the way we see it. The way we see it from our way of existing in time, our size of existing in space. But the actual world is very, very different. And if we look to understand that actual world, we can learn a lot about ourselves, about the people around us, and about how we can sort of try to free ourselves from this delusion to expand our consciousness. So let's start. So the optical delusion is this classical, point of view of physics. When you guys took physics in high school, it was balls rolling down hills and things getting launched into the air. And just, a world where everything is based on our perception, really. Everything is organized, is categorizable, it's independent. If you understand the parts, you can talk about how they interact to come to the whole. You have this notion of Descartes' duality, I think, therefore I am. Like, there's the mind, and that's doing its thing. There's the physical world, and that's doing its thing. And the physical world is this deterministic, understandable thing. And there's a sharp line between the subjects and the objects that they know about the world. We have reality, composed of a bunch of different parts. Don't worry about reading it, whatever. And all these parts are sort of individual little bits, and we can understand them separately. And then the knowledge comes to us, the observer, the subject. The reality is separate from us. We can watch things as it evolves. We can categorize our world and let it do its thing and understand it. But the reality situation is really, really different from that. And in fact, it presents a really different view of the world that's so against our way of understanding things that it makes like in my lab when we study quantum physics, it makes our heads hurt all the time. Like we're sitting there and we have to take breaks to just think, what the hell is going on? So this is not right. So what is the quantum world like? And I'm going to go through the small scale and the very large scale and sort of talk about some of the themes there. So basically, in the quantum world, nothing exists independently. When we think of the idealized classical world, we think we can talk about individual things and how they exist without relation to anything else. But in the quantum world, everything is interconnected. We call it entanglement. You might have heard of the double slit experiment, right? Where you shoot these electrons through two slits, and you see the pattern they form on the back wall. And you find even when you shoot them one at a time, they don't form a pattern like you would expect just point particles to make. They form this wave-like pattern. And that's only explainable through the fact that at small scales, the way we think of entities as either being one thing or being another that's not true at all. Things are really fuzzy and weird at these small scales. There's another thing called entanglement, where if you take, let's say, two particles, you take them together and they both agree that, all right, if you're going to be up, I'm going to be down. And then you separate them apart, but you don't know if they're going to be up or down or not. So you prepare them in this probability they could be up, they could be down, and you separate them apart over miles and miles and miles of distance. And you measure one, and up is up. Then you know the other one is down immediately. And that immediate connection has been shown that it occurs faster than the speed of light. So there is a connectivity to the world that doesn't depend on the distance between things, it doesn't depend on the time it takes for information to reach one to the other. These things become connected across whatever distance is. There's some spooky things going on here. And, I mean, Einstein didn't like that spookiness, but honestly, I think it's really, really cool. Because it tells us that everything is entangled with each other, and also quantum mechanics tells us that the way you try to look at something influences what you see. So back to that double slit experiment. If you try to see what holes these particles go through, you see a regular pattern as if you shot point particles through it. You see like 2 straight lines. But if you don't look to see which hole they went through, if you let them do their thing, you'll see this weird interference pattern where it's light, dark, particles, no particles, particles, no particles. So you see that the way our perception of the world, this picture that I showed you earlier of the world being separate from us, not true at all. We are very much a part of it. And really continued real quickly, we find that basically reality, there's this uncertainty associated with everything. You can't pinpoint things to be here or here. Things seem to overcome the basic binary of existence and non-existence at their fundamental level. That binary that we consider key to our world right now, totally gone in the quantum world. In fact, in the quantum world, everything is like a field. Everything's like a field, and they kind of like, you've got different particles can be thought of as energy knots in this field. Where they kind of, so you've got like an electron field. If you've got an electron here, it's like a knot of energy there. We got a proton here, it's like a knot of energy there. And when we talk about two things interacting, when we distinguish between me and you, we're just distinguishing between different knots of energy. And when we move around, it's just flows of energy, and it doesn't have this categorizable way of that we see the world, where we can say, oh, this is you, this is me, this is a mountain, so on and so forth. Now let's go from the really small to the really, really, really big. So big that we can't even comprehend these numbers either. So originally we have time, so we have space, time, energy, and mass. These things are all considered separate. Einstein comes along, he's a genius. And he cleans these all, and he puts them together. He finds that E equals mc squared, we can talk about energy and mass as being the same thing. He finds that space and time, they can be the same thing. And that when you have general relativity, space, time, energy, and mass are all interrelated with each other. The presence of energy and or mass, because they're the same thing, will warp the literal presence of the space around it. So, as you can see in this kind of photo down here, you've got like a bright light and then like a ring of stuff around it. And what's happening there is that it's literally bending the light from so you've got something here and something here. And this massive object is bending all the light around it, so you get that halo pattern. The reality we see becomes different from the reality that's there because the very reality is being affected by the presence of things. Everything is relational, you can't just consider them separate. Let's talk about relativity. The fact that things depend on your frame of reference. From one frame of reference, if you're moving at one speed, something is energy. From another frame of reference, something's mass. From one frame of reference, there's like, you look at something and it looks this long. From another frame of reference, it looks this long. Like, the fact is that when we think of simultaneity, for example, right, what's simultaneous with me is considered what's simultaneous with you in the audience. But if you look up at the sky and you see a star, you see it's taken like 100 million years for that light to get to you. So let's say I look up at my telescope and I see some aliens dancing, right? It's 100 million years away, 100 million light years away, and these aliens are dancing. And then I sneeze. Is my sneeze simultaneous with them dancing? Or is it 100 million years ago they were dancing and now my sneeze is happening now? The real answer is, there's no answer. The way we think of time in terms of simultaneity just does not match to the actual world. Time is this weird four-dimensional thing. I'm sure you've heard this. It's even hard for like us to visualize it, right? But it's this weird thing where it's not, we shouldn't think of it in terms of moving forward at this like rate. Weird things can happen forward and backwards depending on like what perspective you have. Time looks different. So you've got this world where at the small scale, everything is weird, fuzzy, not defined, related, connected to each other, and constantly changing. At the large scale, everything is weird, fuzzy, connected to each other, constantly changing. And these are reflected in Eastern philosophy as well. You can't really see it here, but this is Niels Bohr. Niels Bohr was a famous physicist, one of the pioneers of the old quantum theory. And this is his coat of arms. And in his coat of arms, he has a yin-yang symbol, and he has, in Latin, the phrase, opposites are complementary. And this is one of the key things also in a lot of Eastern philosophy. The idea of impermanence, the idea of dynamic existence and overcoming binaries is something that you see in Taoism with the yin-yang symbol representing quite literally the fact that you've got your yin and your yang, but even in the center of both is a bit of the other, that they're constantly changing into each other. In Buddhism, impermanence is a huge deal because a large part of our suffering comes to the fact that we try to look at the world permanently. We try to hold on to things without realizing that the actual nature of the world is that it's constantly changing. Things will constantly go and come. And our suffering arises from us being unable to understand that. In Hinduism, there's the notion of a underlying reality to everything, known as Brahman. And that's this sort of like, you can think of it in the quantum mechanical sense even, as this underlying existence of all things, so that when these two particles, for example, are separated, right, and one's measured up and the other one has to be down, they're part of that same underlying existence, and that's why they have these correlations. There's the illusoriness of our perceptions, that reality is constructed by our perceptions. That's another large theme in Eastern philosophy. And finally, there's the idea that everything is relational, that nothing exists in a vacuum. In fact, not even a vacuum exists in a vacuum. In physics, vacuum has a little bit of energy, actually. And even that little bit of energy is like a big deal in a lot of physics, and a lot of people don't even know what's going on there. But the point is that, like, even when we think of things as being isolated, right, in our ideal world here, nothing is like that when we look at the small scale and the large scale. So here's a great example of this. These here are particle tracks. These tracks are taken in, you might have heard of the Large Hadron Collider, or the Higgs boson, or some other like strange terms that sound like a foreign language or something. But basically, these tracks are taken when you take little subatomic particles and you shoot them at like 99.999% of the speed of light at each other. They collide and they form all these beautiful tracks. And you can't really see it here, but you see there's like a V here. And in here there's a couple other V's. These V's are literally the process of energy turning into mass. You've got a particle of light that comes along, it hits something, and boom, it turns into an electron and an anti-electron. That's the process of creation and annihilation that goes on in the soul of everything around us. And at every little point, these particles are colliding, or doing all sorts of things, are creating or annihilating. Energy knots are just turning into other energy knots. And we look at it and we see mass and energy interchanging, but at its core, it's just flows of energy. And in fact, this reminds me a lot of something in Eastern philosophy called the dance of Shiva. The dance of Shiva is also described as the process of creation and annihilation, this cycle that sustains the universe. Shiva, there's actually a statue of Shiva in 2004 was installed right outside the big particle collider in Europe. And Shiva's right hand, I say Shiva, technically this is like a character that's a manifestation of Shiva, but for simplicity. In Shiva's right hand there's a drum. This drum represents the beat of creation and the syncopation of the cycles that everything in the world is tuned to. In Shiva's left hand, there's a flame. This flame is the process of destruction, that everything goes through creation and destruction, and everything's constantly interchanging there. Shiva stands on a demon that represents ignorance. These illusions are delusion of optical consciousness, our optical delusion of consciousness, where we think the world is this way, instead of trying to understand what's the real nature of the world around us. Surrounded by a ring that represents, the cosmos doing its thing, and through the whole thing, if you look at Shiva's face, stoic, peaceful, at peace, centered. And that's the idea that I find really cool, that there's this Tao of physics, if you will. There's this flow to the universe, these laws, these patterns or whatever, and these patterns are largely probably due to our perceptions. But they manifest themselves in all these different ways, and when we look at these patterns, we can learn things about our lives. So why does any of this matter? Well, one, I think understanding the world is a really cool thing to do. But really, besides that, understanding nature, I think, is really important, especially because a lot of this has led me to a pantheistic view, where nature is almost divine, in my opinion. Where this process of creation and annihilation, these processes that sustain the life that we have today, at the very large scale and the very small scale, we need the world to be wacky and weird like this in order to have what we have today. And yet, we worship this quote by Hubert Reed says, "Man worships an invisible God and destroys a visible nature, unaware that this nature he is destroying is this God he's worshiping." And I'm really a proponent in that. And I think that that's what I see in a lot of physics. In physics so what are the three things we see? Unity. To me that translates to love. When there's unity of all things, when everything is interconnected, in my life that translates to the fact that I'm connected to all of you. That even though I have my optical delusion, where I just see the world from my perspective, we're all part of this same larger entity. We're all different manifestations of it, and coming together and recognizing that is a way of us to get beyond just our limited perspectives and to really try to move forward in the world and understanding the world. Everything is dynamic and changing, and I think that manifests itself in my life in work. And not just work as in I gotta do this, but in the fact that everything in the world, from atoms moving around, to animals doing their thing, to galaxies and planets moving around, everything is driven by this flame, by this this need to be constantly doing something, constantly changing. And for me, when I'm like working and I'm doing something I enjoy, that to me is a manifestation of that flame of life within myself. And I see that all over in physics, and I see that in my life, and I see that at the biggest scales of the universe. To me, that sort of coming together is really cool. And the last point there, which you can't really see well, is perception. That our perceptions construct our reality. And not just in terms of quite physically, literally, well, if I think differently, everyone here won't be here. Not necessarily. But our perceptions construct our reality at the smallest of levels, and additionally, at the fastest of levels in relativity, your perception constructs reality. And further, at this level, how I choose to look at the world seriously influences how the world will seem to me. It may not look different at first, but how you process and construct the world can largely be influenced by your perceptions. That's a big theme in Eastern philosophy, and that's something I see exactly in physics. So I guess my goal with perception is to be more mindful, to expand my consciousness beyond just this perception of myself as being separated from all of you, and to realize that on a quantum scale, we're all connected. On a cosmological scale, we're all connected. We're all changing, and we're all part of the very same reality. We just see things differently because we are in our very small little corner of space and time. But if we expand beyond that, we get a view of the universe that is absolutely mind-blowing. And it helps, I think, influence our own lives. So some last thoughts. I'm going to leave you with a quote from Khalil Gibran. He's a poet who wrote a book called The Prophet. And it says, "You work that you may keep pace with the earth and the soul of the earth. For to be idle is to become a stranger unto the seasons and to step out of life's procession that marches in majesty and proud submission towards the infinite." And I really think that that's what I was talking about earlier in terms of just recognizing that everything is changing. And yet in changing, everything is changing in its own way. And that change is part of this underlying connection between everything that causes everyone to change, that causes you or I to want to go about our lives in the way that we find passionate, that causes these particles to want to be vibrating, to want to be going here or there, that causes the flows of energy at the smallest and the largest levels. So yeah, this is just my perspectives. These are the parallels that I see between Eastern philosophy and physics. There's a lot more there. There's also some things that disagree, but on a whole, like, there's some absolutely mind-blowing stuff. Like, so real quickly, I do some research at WashU. My PI is right there. Hi, Kater. And some of the research we do kind of confirms part of this, in that we look at these quantum trajectories of these quantum mechanical systems. But in order to look at these trajectories, we can't just look at the system. We have to look at the environment around it. You can't just look at the individual thing. You have to see how it interacts with its surroundings and what its surroundings look like in order to get an idea of what the hell is going on in the first place. That to me is a confirmation of the fact that things are connected in ways. Just because we don't see connections doesn't mean they're not there. And I think that's what I'll leave you guys with. So thank you.